Okay, so today we're going to learn a new method than we learned yesterday. So again, we're going to solve systems of equations, but this time we're not going to solve them by graphing. And here's why. Graphing can become an issue because if I have a graph, and let's say one of my lines does this, and my other line does this, I know these things will intersect, but it might take it a very, very long time. And if it falls outside of my graphing range, which is like down here for me, if it falls outside my graphing range, I don't get to see it. So I have to keep extending my graph, and it could take a long, long time. So graphing comes in an issue when you have your points way outside. Or if you kind of get decimals, like it's not easy to figure out where these things are. And yesterday I think you had issues with, like, where does it exactly work if you're just plotting it by hand, where you're kind of guessing where that's going to be. So we're going to learn a new method today. This is called substitution. And the reason it's called substitution is we're going to substitute some things in. And since we know that they're going to intersect, we know that their x values are the same and their y values are the same. So if you were giving me this first problem, I wouldn't graph this today. I'd go, oh, well, x equals 3. So if x equals 3, I know what x is. X is 3. And in this equation, I don't have to write x anymore, because we know what it is. We can just take this and put it into there. So we would get our new equation that y is equal to 7 times 3 minus 10. Which that would give me y equals 21 minus 10. And so y would be 11. Now, after I got my two answers, which I have y equals 11 and x equals 3, we're going to write that as a point. And a point always has an x value and a y value. So this answer that we would get would be 3, 11. And that would be my final answer. Let's try a second problem. Okay. So this second problem, they give me that y is equal to 2x minus 5, and they give me y is equal to 11. Well, again, now I already know what y equals. Y equals 11. So in this equation, instead of writing 11 or y, let's write 11. So we'll have 11 equals 2x minus 5. And now I'm just going to solve for x. So when I solve for x, we're going to add 5 to both sides. I'll have 16 equals 2x. We'll divide by 2. We'll divide by 2. We'll have x equals 8. So again, we have both of our things that we need because we need an x and a y. So for my point, I'm going to have 8, 11. Let's try another example. In this example, we don't have things as nice as we did last time because we don't have a single y value. It's not like y equals a number. We kind of have two equations, and we would have graphed this the day before, but let's see how we could use substitution. Well, I know that y is equal to 3x plus 6, and y is equal to 2x minus 3. Well, why can't we just do the same thing that we've done for the previous problems and take what we know what y is and plug it in over here? So that's what we're going to do. We're going to say that 3x plus 6 is equal to 2x minus 1. Okay, so all I did was I took what I know what y equals, which is this thing, and replaced it in for that y up there. And now I'm going to solve. So I'm going to subtract 2x. I'm going to subtract 2x of x plus 6 equals negative 1. Subtract 6. Subtract 6 of x equals 7. Now that's part of my answer, but it's not my whole answer because I don't have, for my point, I don't have a y value yet. So how we're going to find that y value is, oh, now I have an x value. I can take that x value and plug it in up there and have y equals 2 times 7 minus 1, which means y would equal 14 minus 1, or y would equal 13. Then I have my two values, so I can get my point. Okay. Again, it's all about taking what you know, equaling something, and plugging it in for something else. Let's try one more problem. Okay. So for this one, we have something that's in standard form, and we have something that is in y-intercept form. So again, this one's a little bit weird, but we're going to use the information that we have. We know that y equals this thing. So since y equals that, I could plug it in for y and get 3x plus 2 times negative x plus 1 equals 5. So again, whatever y equals, we're going to plug in for our other y. And now we're just going to solve. Well, this is kind of a distributive property. I have my 2 on the outside. So I'm going to distribute my stuff on the inside. And I'm going to get 3x plus, well, that would be negative 4x plus 2 equals 5. Now that I have this, we're going to combine our like things. So 3x and negative 4 will become negative 1x plus 2 equals 5. I'm going to subtract 2 of negative x is equal to 3. I'll divide by negative 1. I'll divide by negative 1 of x equals negative 3. That will be one of my answers. Now that I have one of my answers, what I can do is I can take this and I can plug it into up here for x and see what my y is equal to. So I'm going to have y is equal to negative 2 times negative 3 plus 1. So y is equal to 6 plus 1. So y is equal to 7. And again, I'm going to take that and make that my point. So the basic idea behind this is what you need to do is you need to make sure you have something where y is equal, and then you can plug it in and solve for the different variables. After you solve for one, you plug it back in and solve for the other. That's essentially how substitution works. Let me know if you have any questions.